Yeah, welcome back. Today we will discuss about the C interfacing C program for blinking of an LED with a delay. So in the previous session, we have seen the blinking of LED continuously. Now we'll generate some delay between on and off for the LED. Okay, so we'll directly go to the program. So we are going to declare the header file stm32 f4xx underscore hal.h, and another most important header file ash include board underscore led.h. So we are going to start the main program, and we are going to declare an unsigned integer num which is equal to 0 and another unsigned integer index I which is again initialized to 0. So next we are initializing the LED function, and then uh, we are going to the while loop. So we are going to give the delay between on and off, and that delay we are going to produce with the help of the index indexing of the I. Okay, so for I equal to 0, I less than 50,000, I plus plus LED on num means on num. So till I becomes 50,000, the LED will become on, and once it gets on, after 5,000 increments, LED is getting to get on, and then LED is going to get off, and again it is going to be delayed for till I is becoming 50,000. So like this until the while loop is 1, this loop is going to be continuously worked, and for every duration between on and off there will be a delay of 50,000 increments of I. Okay, so let us demonstrate with the help of a. So this was the blinking of the program, LED program. So open the Kinsey software as usual, then configure it. Okay, so before configuring, give the project name. So I am giving it as a delay. Yeah, select the software pack, select the our device STM32F401RE. Okay, next configure for the IO devices. Configure for the board first. Our board is nuclear board, so configure it. Then select the LED. Then select the core type. Next is device. Set up the device. Then framework is classic framework. And once the configuration is done, give OK. So now you have configured it. Next, go to the target, update all the configurations. Update the configurations, all the 4 configurations. Then go to the system source file, add already written C file. Already I have written the C file, so directly I'm importing it. Otherwise, you open the new file and write the program. Okay, so once the program is done, you just build the program and make sure that it is free from errors. Yeah, so make sure that the device is connected properly to the system. Okay, so see here, so I got an error. So once again reconnect it and configure it. So even if you forget to configure the device, so it will be unidentified. So configure it again with the debugger and dump the program using the flash drive. Okay, so once it is done, you debug the program. Now it is connected. And check the cortex. So see, LED is been glowing with some delay. You can able to feel the differentiation. You can able to feel the differentiation between the two things. So now I'm increasing the delay. I'm increasing the delay by 15,000 times, and I'll save it. I will debug it and then build and debug the program. Now we can clearly see the impact of increasing the delay in the board, isn't it? Okay, so this is how we can increase the delay or decrease the delay uh, for any device. So if you want to increase the delay, we can make sure of uh, putting one more for loop in the C program. Okay, so thank you. With this, I'm ending the session.